All right, page 314 is where we're going to start. Your homework was on pages 313 and 314. We're going to start on page 314, looking at the 3 through 11 odd. Number 3 in that review section, they gave us 4 over the square root of 3. It says to rationalize the denominator. What do I have to do to rationalize this denominator, Adam?
You need to multiply the square root
Times
3.
Well, not times 3, times the square root of 3, because I want it to become a square root of 9, which in turn can just become a plain old ordinary 3, right? To rationalize, remember, means to take the root. All right, so to take the root, I need to change it into something I can take the root of. But as you said, multiply by a square root of 3. But what we do to the bottom, so the top becomes
4 times the square root of 3.
And can I do anything with that?
No.
That's okay, we don't really care. We're just going to keep it. If we could reduce, we would, but 4 and 3 don't cancel. You can't cancel radical with non-radical. I'm going to have this for number 3 for your answer.
I might have just been going too fast because I left it as a 9.
Oh, careful there. Lana, on the next one, we got a 5 over a cube root of 7. This one's really annoying, but I can't take the cube root of 7. In fact, the smallest thing I can turn this into, Lana, is a cube root of...
It was the cube root of... See, I don't know what I mean.
Well, Lana, what are numbers we can take cube roots of?
16.
No, you can't take the
16.
cube root of 16. 8.
27. 8. What is it? 64. 125. 216. And what's next?
That's a good question, because that's the number we need, because you can't turn 7 into any of these.
Yeah,
what's the next number? Class 7 cubed?
343.
343. If you don't remember, you multiply 7 times 7 times 7 until you figure it out, or you go back and look it up in the table that you copied weeks and weeks and weeks ago. But 343 is the target number, and to get a 343 in my radicand, I'm going to have to multiply top and bottom class by...
The cube root of 7.
Not the cube root of 7, that would give me a 49. I need the cube root of a 49. I need 2 more 7s. I got 1 7 here. I need 2 more 7s to get a total of 3 7s in there, which means my numerator, 5 times the cube root of 49, which can't do anything with. We're going to leave the 5 times the cube root of 49, but cube root of 343 class comes out to a nice, easy 7. So a bit obnoxious how big we had to go here. Yeah, that's the way it goes in life. How many had that answer?
No.
Okay, only Josh, only the guy who's exempt from his exam. Good job, Josh. Questions from the rest of us who have to do this on the exam.
I just didn't know how big you have to go.
You got to, until you get a number that 7 can go into. 7 can't turn into any of those, so you got to keep going. Let's go to the next one, number 7. Now here we have a 2-term radical denominator. Let's come back to Lana for redemption. Lana, anytime we have a 2-term radical denominator, I have to multiply by the...
Conjugate.
What's the conjugate?
2 negative square root of 3.
And what you do to the bottom?
I do to the top. That's the part I messed up on.
All right, so, Lana, in the top.
1 or 2 minus square root of 3.
Because anything times 1 is itself. What do I have to do in the bottom? Well, I could.
Or
Anytime we multiply with the conjugate class, we've created a sum and difference on purpose so that we could...
Square the first, square the last, minus sign between them.
So, Lana, back to you. Square the first.
4.
Square the last.
Square root of 9.
Well, which is 3. Because class, when we square a square root, we get the radicand. And then you said put a... And 4 minus 3 just comes out to a 1. But anything over 1 is itself, so we could just say 2 minus square root of 3. How many have this answer? On number 7. All right, number 9. We've got, it's not a quadratic equation, it's a cubic equation.
Oh, wait, I have the 1, but I didn't have the 12.
What do I need to do to solve equations? It's kind of like a quadratic, but it's not a quadratic. Josh? I need to factor. What do I factor first? What do I always factor first, class?
The
common factor. And what's common, Josh?
2x.
2x. I'm going to factor that away, and in parentheses I'm going to leave
x plus 3 and x.
Well, how about x squared
Oh, yeah.
negative x negative 12?
I went to the...
All right, and then, Josh, after we factored out the common factor, then we'll do what you were doing. That's the backwards FOIL. So you may have done both steps in your head because you're just that smart. But what do I get when I backwards FOIL?
X plus 3 and x minus 4.
There we go. All right, and now, how many factors do we see, class?
3.
3. Because it's a cubic. So I'm going to get 3 different answers, but every factor, class, must be set equal to 0. So when I set 2x equal to 0, I've got to get rid of the 2 by dividing both sides by 2, class. I'm going to get 0. Here I'm going to move the 3 over as a negative to get x equals. And here I'm going to move the 4 over as a positive to get x equals. And I have 3 different answers to my equation. How many has 0, negative 3, and 4? Questions on that?
I just forgot to write the answer.
You didn't finish it. I'm solving this equation, but I don't want to write any answers down. I'll do all the rest of the work. Just want to get the answer. All right, look at the next one, number 11. We have a 12x squared, negative 17x, negative 5 is equal to 0. And this really is a quadratic. But it's the same steps. It's set equal to 0, and then, Dylan, we factor. So this one's a little annoying, though, to factor. 12x squared, there's a lot of ways we could split that up.
4x and 3x.
That's the way I would start. I mean, it could be 6x, 2x. It could be 1x, 12x. But I'm going to try the 3x, 4x first. The negative sign at the end tells me alternate sign. So we've got to have a positive and a negative. And then the only way to split up a 5,
1 and 5.
1 and 5. Let's see what happens here. Outer
Negative 20.
and inner
Positive 3x.
gives me
17.
the negative 17x. So it actually got it on the first try. Doesn't always work that well, but this time it did. Once we factored, then, Adam, we got to take each factor equal to 0. And this time, it's a little more annoying. Here, all I had to do was move the 3 over. All I had to do was move that negative 4 over. Well, here, I've got to first move the 1. Then I've got to get rid of the 4. What do I end up with here?
X equals 1/4.
Almost. When I move the 1 over, it becomes
Negative 1.
-1. And then we divide away the 4, and that's where we get -1/4. Same thing happens here. 2 steps. First, I move the
5
as a,
positive.
and then I,
And you move the 3.
when I move the 3, divide the 3. Because it's not a separate term. So we can move terms. 3 just gets divided. So we end up with?
You have positive 5/3.
Positive 5/3. 3x equals the positive 5, and then when we divide away the 3, x equals positive 5/3. How many of these answers for the last one there? I guess technically we'd want to move this negative in front of the fraction. So it's not -1 over 4, but negative a fourth. How many of those answers?
Had a copy.
Okay.
Negative 7x instead of
Oh, ooh, that's got to be frustrating because then you're trying to figure out how to get a 7.
I don't know why I just forgot how to do those.
Well, I guess you could have gotten a 7 if you did 12 and 1.
Yeah.
Okay, so it actually would have worked out for an outer inner, wouldn't it? It just, okay. So the equation you solved, you probably had the right answer. It's just, it wasn't the equation they wanted you to solve. All right, questions on that? Questions on this? All right, let's get to what we were working on in our last lesson. We were working on solving incomplete quadratic equations. Now, in general, class, a quadratic is an equation that has
X squared as its
highest power. X squared is the highest power. Thank you, Joshua. Class, what's a quadratic?
X squared is the highest power.
And a quadratic always has
2 answers.
2 answers, right? That's what made the one I just erased not a quadratic. It had x cubed and therefore 3 answers, okay? Whatever the highest power is, that's how many answers you'll get. But in a quadratic, I said there's really 2 types of quadratics. There's complete and incomplete. We said proper quadratic form is ax squared plus bx plus c equals 0. If you have actual numbers here, then that means you'll have actual x squared and actual x. We call that complete. The x squared has its x. But if the b is a 0, then there isn't an x term at all. And if it's missing an x, that's when we call it an incomplete quadratic, or sometimes called a pure quadratic. That's what we were working on as we flip back to page 313. We said for a normal quadratic equation, class, we set it equal to 0. Or a complete quadratic, we set it equal to 0, and then we factor. It's what we do. But on a problem like number 2, x squared equals 100, rather than setting it equal to 0 and factoring, we said isolate the x squared and take the square root. What are those two steps, class?
Isolate the x squared and take the square root.
Well, they already isolated the x squared, so all we have to do is
Take the square root.
but it's important to remember there are two square roots of every number. So when we take the square root of 100, there's actually two square roots.
Positive, negative 10.
Positive and negative 10. Now, if they just wrote this on a paper, we saw the square root of 100, well, there's an understood positive in front of it. So we know we only want the principal root, or the positive 10. But when we put the square root, we have to account for both possibilities, because either of them squared would give you 100, so positive and negative 10 are answers. How many have those for number 2? And you just figured out the positive, negative, minus a point. Now, as we look at number 4, x squared equals 12, same thing. They've already isolated the x squared class, so all I have to do is
Square both sides.
isolate the x squared, take the square root. What are they, class? Isolate the x squared, take the square root. They've isolated the x squared, so I
Take the square root.
The difference is, unlike problem 2, where the square roots come out rationally, here, of course, the square root of x squared class is just x, but the 12, I can't take the square root of 12, not evenly, so what do I do if it doesn't work out evenly? Factor it, reduce it, right? Split the 12, Joshua, into
3 and 4.
Or do I take the square root of
4
to get
2
times the,
square root of 50.
and of course, since we're solving, since we put that square root there, we're not going to forget the positive, negative. Again, if it had been there itself, we wouldn't need the positive, negative. There we go. Of course, we would never leave the square root of 12 as an answer. Always reduce it down, right? Dylan. And you were turning around looking at Josh. I'm picking on you. All right, how many had positive, negative 2 times the square root of 3 on number 4? All right, so just minus points. I'm making mental notes there.
You really are picking on me.
Looking up the next one, we have the x squared equals 56. Josh thought I was picking on him. I kind of was. All right, x squared equals 56. Once again, they isolated the x squared class. We just
Take the square root.
and this time, Dylan, how do I factor the 56?
4 and 14.
Good. We would think 8 and 7, but that's with a cube root. For a square root, we need 4 and 14, which we didn't memorize that high on our 4 times tables as kids, did we? We went up to 4 times 12 equals 48. We never went to 4 times 14 equals 56. Good job solving it, though. Our final answers?
I lost it. X equals positive negative 2 times the square root of 14.
There we go. There are our answers. Look at the next one. X squared equals 32. Adam, we take the square root. We get x equals?
2 times the, 4 times the square root of 2.
Positive negative 4 times the square root of 2 as we factor into 16 times 2. Or what I think he did, he said 4 times 8 and then realized the 8 could factor again into 4 times 2. So pulling out a couple of 2's. To get positive negative 4 times the square root of 2, how many have that for number 8? All right, number 10, Lana, with x squared equals the 35. Again, have to take the square root. Can I reduce the square root of 35?
I just put x equals, positive, negative, square root of 35.
Good, there we go.
I don't know, I forgot positive, negative on my phone.
Okay, well, the lesson learned, right? That's why we give you homework, so you have an opportunity to make these mistakes to learn from them.
Other than that, I've been getting them all.
Excellent, excellent. Positive, negative, square root of 35. Hey, sometimes you can't do nothing with them, just leave them. Number 12 is an interesting one. We have a 4x squared equals 25. Josh, this time the x squared is not isolated. I have to isolate it myself. What do I do?
You take the square root.
Not yet.
Oh.
It's not isolated yet. Now, technically, by the way, it would work, what he's proposing, but it's best to isolate first. Yeah, it's going to work out this time, but as a general rule, we want to use something that's always repeatable. Let's isolate this. So how do I isolate the x squared? Don't make this hard.
Just divide by 4.
Divide by 4. Absolutely divide by 4. Easy. That gives us x squared. Now, the downside is it gives us a fraction, 25 fourths. But that's not a problem, because my next step is to...
take the square root.
And that's also not a bad thing, because the square root of 25 fourths comes out rational.
5 halves.
Positive, negative 5 halves. Now that's the same answer you would have had if you took the square root a moment too early, but it wouldn't always work like that. So wait until it's isolated, and that way you'll get an answer that's consistent. How many got the positive, negative 5 halves?
It's just because I looked at it and
You happen to see both sides were rational.
2x equals 5 because...
Careful.
Because 4x squared.
So you just didn't finish it out, number one, with positive, negative. Number two, getting the x by itself. Remember, you are not done until x is completely by itself.
Yeah.
But we're going to start class by isolating the x squared. So for instance, on number 14, it gives us a 5x squared equals 100. What do I have to do first, Dylan?
Divide by 5.
Divide by 5 to isolate the x squared. When I divide both sides by 5, I get x squared equals 20. And then I will
Take the square root.
And when I do, what do I end up with?
X equals positive negative 2 times the square root.
Good. Factor in 4 times 5. How many had positive negative 2 times the square root of 5? On 14.
Do that.
I had to like slow
Questions on that?
Sounds like this is.
On the next one, Adam, we have a 2x squared equals 5. What do I need to do first?
I know we move the 2 over and divide it by the 5, so you have 5 2s.
All right, so x squared equals 5, 2. So isolate the x squared, divide away the 2. Then?
You have to multiply by 2.
No, I don't. Not yet. No reason to yet.
Well, you do something to that thing, I don't know what you call it. But like,
Class, help him.
I don't know what to do.
Take the square root. What are my 2 steps?
Isolate
the x squared, take the square root.
What are they, Adam?
Isolate the square root.
Isolate the x squared, take the square root. What are they, Adam?
Isolate the x squared.
We did that.
Square root.
Take the square root. Now when I try to take the square root of both sides, Adam, now I'm like, wait a second. I can't take the square root of the denominator. So
Multiply by 2.
So instead of a 10 or instead of a 5 halves that I'm taking the square root of, I'm really taking the square root of
10 over 4.
10 fourths, which again doesn't work out evenly, not rationally, but at least the denominator will be rational.
So the square root of 10 over 2.
Good, but don't forget. Lana. Positive negative. There we go. All right, questions on number 16. A little bit more tricky because you had to rationalize the denominator in your answer. Questions?
No.
All right, look at the next one. Number 18, we have a 2x squared minus 1 is equal to 0. We're going to do several things here, Lana, but my first main step is to
isolate the x squared.
isolate the x squared, which requires us to do 2 things this time.
Add the 1.
Add the 1, then
Take this.
not yet.
Oh wait, no.
Wait, it's not isolated yet.
Divide by 2.
Divided by 2. So I end up with my isolated x squared equal to 1/2. Now, to be fair to Adam, in the last problem, he was trying to get a denominator that would have been rational to begin with. If we wanted to do that, I suppose it's not a problem. But the reason we're doing it is because of the square root, right? So instead of a half, Lana, I want to take the square root of
you could do 2 fourths.
2 fourths, which works out much better for us. We get what 2 answers?
1 positive negative 1/2.
What's the square root of 2? Well, it's just square root of 2.
No. Square root of 2 over 2.
There we go. Positive negative square root of 2 over 2. How many had those answers for number 18?
Answer.
Questions on number 18? Look at number 20 now. The last one we had for homework, it's an 8x squared equals 5 minus a 2x squared. And Josh, we say isolate the x squared. There's 2 different x squareds. We can't have 2 different x squareds, can we?
No.
Thoughts?
Move the negative 2x squared as a positive.
Yeah, get rid of the little one. Just like we would do with an x, get rid of the little one. Now, if there's 2 x squares, get rid of the little one. Bring this guy over as a positive 2x squared, you said, to get
10x squared equals 5.
And then we can isolate the x squared.
Divide by 10.
Divide by 10. When I do, I have my isolated x squared equal to 1/2. But kind of like the last problem, very much like the last problem, you can't take the square root of a half. In fact, you can't even take the square root of the 2. So we change this, instead of taking the square root of a half,
2 fourths.
square root of 2 fourths, as we multiply top and bottom by the 2 to get
the square root of 2 over 2.
minus a
Positive
point.
negative.
Positive negative. And there are our answers for number 20. Questions on this? Questions on this? Go back now, and I want you to do numbers 7, 11, 17, and 19. 7, 11, 17, and 19. Starting back on page 313. 19?
Yes.
Oh, don't we hate fractions? We've hated fractions all year in our equations, haven't we? What have we always done to get rid of fractions?
Multiply by the LCD.
Multiply everything by the LCD. Don't change now. Still multiply everything by the LCD.
No, why is there 5 and there's only 4?
I added one more at the end for you if you happen to finish quickly. Very, very astute observation there, Adam. Well done, sir.
It is, but I got it.
Since you finished 19, there's one more on the chalkboard at the end for your work. You're right, that is annoying.
I got that though.
Good job.
I didn't get that.
All right, let's take a look at these four real quick. The first three should not have been any trouble for us at all. Check your work. Positive negative 3 squared root of 3 on the first one, number 7. Yes, shake or rattle. All right, on the next one, positive negative 2/3. Again, no trouble at all, right? The next one, also no problem. Positive negative 3, correct? Yes, no.
Yes.
Okay, now the next one. Did we multiply everything by 6?
I did it. You multiplied the negative 2.
Everything. There's a reason I say it weird like that, is so you'll remember everything by 6. So should have got 9x squared minus 12 equals 2x squared. Bring the 2x squared over as the little one to get 7x squared, but send the 12 over as a positive. Divide by 7, get 12 sevenths, which we have to take the square root of. Top and bottom by 7, get 84/49. So there we go. Leave the square root of 84 just for a moment. All over 7. But 84 factors into 4 times 21. Should see the 4 in there. So positive negative 2 squared root of 21. All over 7. Questions on that one?
Wow.
Do the last one on the board if you haven't already. 5x squared minus 7 equals 8x squared minus 19. Do that last one on the board very quickly if you haven't already. If you have, just sit there with a smug look on your face for just a moment.
I got positive negative 9/14 on that number 19.
Oh.
I just tried to roll with fractions.
What do we need to do here, Lana?
Move something over.
I'm sorry?
Move something over.
Yeah, what?
Negative 7?
We could, but I wouldn't yet. Always get rid of the little x. Well, I don't have x. I've got x squared. So get rid of the little x squared, Lana.
Move that to negative 5x.
There we go. Start there. Get the x. Get only a single x squared in the problem. Because again, we have to isolate the x squared, but there's 2 of them. Which one? We'll get rid of one. Now I've got a negative 7 equals
3x squared negative 19.
Now I can work on isolating the x squared, Lana.
Move the negative 7.
That would isolate the
No.
x squared? What would isolate the x squared? What's-
Dividing it?
What's with the x squared, Lana?
The 3.
And
And then the negative 19.
if I can get rid of those two things, x squared becomes isolated, right? Just like we'd solve any other equation, it just happens there's a squared on it. So what should I do?
You divide by 3.
Not yet, it's so attached to that 3. Don't take away the 3, Lana. Not yet, give it a little more time.
The negative?
Oh yeah, it's not attached to the negative 19 anyway, let's get rid of that.
Positive 19. So, can't. 12?
12 equals, that's a bad thing for this week.
Today.
All right, 12 equals 6. So just like any other equation, right? Get rid of the least attached thing, and now, sorry, son, I know you love that baby blanket. The baby blanket has got to go. He doesn't sleep with a baby blanket anymore, by the way. It's great strides this year.
Did you cut it up this morning?
We didn't have to get that far. It just vanished one day. And he didn't notice. So he was obviously ready to move on. Good job, wife. All right, so anyway, but baby blanket, it's time to go. Time for him to grow up. He's graduated from kindergarten now. No more 3. What do I do?
Take the square root.
Oh, get rid of the 3!
Get rid of it. 4 equals x squared.
There we go. Divide away the 3. 4 equals x squared. Now that it is isolated, only now that it's isolated.
Take the square root.
And what do I get for my answers?
Positive negative 2.
Equals x. And there we go. How many had that for the last problem?
Do
Questions on that? There you go, Carpet. All right. Take a look at number 21, if you would, please. Copy it down there in your notes. We have a 2x plus 9 quantity squared equals 16. 2x plus 9 quantity squared equals 16.
Is that one in our book?
No, that was not in your book. I just made it up for you to get some extra practice with stuff.
Yeah.
All right, looking at this. I do that all the time. Get used to it. All right, looking at the last. You should be used to it by now, I should say. All right, looking at this one here. It doesn't say x squared. It says 2x plus 9 squared. But you see that if it had said x squared equals 16, I would just take the square root of both sides, and I would get x equals positive negative 4, right? Well, in a problem like this, it's not an x being squared, it's this whole thing being squared. But I can still, do this with me, take the square root of both sides.
Oh.
Because just like this square root and square cancel, this square root and square cancel, and it just leaves me with a 2x plus 9. But over here, just like before, when you take the square root of 16, you get positive negative 4. Over here, when I take the square root of 16, I get positive negative 4. It's just not an x equals, it's a 2x plus 9 equals. Make sense? Which means I'm not done. Which means now I got to solve for x. Well, how do I solve for x? Get it by itself. What do I do to get it by itself?
Negative 9.
Move the 9 over as a negative. Now that's kind of weird. And then divide away the 2. Now look at what we've got here, class. What I've got, and what you should have on your paper as you're doing this with me, is positive negative 4 minus 9 over 2. This is 2 different answers. Follow along with me. This is positive 4 minus 9, or negative 5 over 2. And it is negative 4 negative 9, or negative 13 over 2.
That is weird.
And there's my 2 different answers.
Yeah,
Make sure you have that copied down, and we're going to do a few more of these. This is the same thing. It's not another way. This is the exact same thing we just were doing. We isolate a square, and we take the square root. It's not an x squared. Look at number 23. Write it down. X negative 8 squared equals 81. Again, it's not a plain old x. It's an x negative 8 squared. But I can still do the same thing. I've got the squared thing isolated, so I take the square root. And on the left-hand side, when you take the square root of something squared, the square root and the square, class, cancel. You're doing this with me, Lana. And I'm left with, on the left side, class, x minus 8. But on the right-hand side, when I take the square roots of 81, class, I get
positive negative 9.
But I'm not done. I just have to finish solving for x. And to finish solving for x, I've got to get rid of the
Negative.
It's not an 8, it's a negative 8. Good, by moving it over as a positive 8. And these are my two answers, positive negative 9 plus 8. But this means positive 9 plus 8
17.
and negative 9 plus 8.
Negative 1.
And there's my two answers. Copy down number 24. Walk me through it, Dylan.
Square both sides.
What?
Hmm?
Square both sides?
I mean, take the square.
Square root of both sides. There we go. All right, we already got a square. Square root of both sides. And what do I get?
X plus 3 equals positive negative 5.
Perfect. Any questions on what Dylan did in the first step?
No.
Now what do I need to do, Dylan?
Move the positive 3 over as a negative.
And what are my two answers, Dylan?
2, negative 8.
Good. 5 minus 3, which is 2, and negative 5, negative 3, which is negative 8. There's my two answers. Now, what's the application of this? Let me show you something here. This is going to be the final thing to kind of show to you. This is really more of an Algebra 2 concept, but I want to show it to you now. If I had x squared equals 9 class, we would just take the square root, right? What would I get?
Positive 3. No positive negative.
X equals positive negative 3. What if it was x plus 1 squared equals 9? What would I do?
Take the square root.
Take the square root, just like I did here, right? But instead of x equals positive negative 3, class, it would be?
X plus 1 equals positive negative 3.
And then I'd have to move the 1 over as a negative to get 3 minus 1
2.
and negative 3 minus 1.
Negative 4.
But what if it said, write this down, x squared plus 2x plus 1 equals 9? Do you see? It's the exact same thing. That is x plus 1 squared equals 9. So I could literally just change this into that. And I get these two answers. Write this down if you would. X squared minus 6x plus 9 equals 4. X squared minus 6x plus 9 equals 4. Rather than setting this equal to 0 and factoring, which I could do, I could also rewrite this perfect square trinomial class as
X minus 3 quantity squared.
x minus 3 squared. Because by writing it as a perfect square trinomial, all I have to do, class, is take the square root. Adam, what do I get?
X negative 3 equals positive negative 2.
And then to finish it, class, I need to move over the
Negative 3
as a,
Positive.
to get what answers, Lana?
5 and 1.
There we go. Boom. Now, write this down. X squared negative 6x negative 3 equals 0.
Wait a minute.
You can't solve this by factoring. Normally, set everything equal to 0, factor, set the factors equal to 0, and so forth, right? That's my steps for quadratic equations. You can't factor that. Well, when you can't factor, you can do something called complete the square. You can leave a gap and kick the constant out. So what I'm going to do, stay with me real quick. What I'm going to do here, you're not going to be tested and quizzed on this on the exam. This is kind of just a preview of something you're going to see in Algebra 2, but I want you to see it this year so it's not the first time you see it next year. Move that negative 3 over, class, as a positive 3. And now, fill in the gap. Well, we know what goes in the gap. For a perfect square trinomial, x squared minus 6x, we need a plus 9. How would we get that if we didn't know? Cut the b in half and square it. Cut the 6 in half and square it. 3 squared is 9. But what you do to one side, I've got to add the 9 to the other side as well. And this is going to give me the perfect square trinomial, all equal, class, to a 12. So that the perfect square trinomial, just like a moment ago, can become an x minus 3 squared. But instead of equaling a 4, it equals a 12. And then I take the square root of both sides, doing this with me. Of course, the square root of x minus 3 squared, just cancel the square root and the square to get x minus 3. But when we try to take the square root of a 12, it doesn't work out rationally, does it? That's because it couldn't factor in the first place. If it doesn't factor, it means you're not going to have rational values. We're going to get a positive negative 2 square root of 3. Now here's the nice thing. When you move the 3 over as a positive, you can't combine anything, so you're just done. You just leave it like that, instead of having to combine with the other value. Let me show one last problem. I know we're just a nudge over time, but for the sake of the recording and sake of posterity, let's show one more problem. Let's suppose we looked at this problem. X squared plus 6x minus 112 equals 0. I don't want to factor this. I don't even want to try. But I don't have to try to factor it. I can zoom out just a little bit. First of all, I can complete the square. Just like before I can ditch the negative 3 class, I can ditch the negative 112 to get
Positive 112.
And what goes in the gap?
Positive 9.
A positive 9. Half and square, we get a positive 9. And we put it on
Both sides.
both sides. Are you copying this down with me? So that this perfect square trinomial becomes,
X minus 3, 1 squared.
right, x plus 3 squared, PST and a binomial squared. And on the other side, 121.
That's 11 squared.
That comes out evenly when I take the square root, which means this could have factored, but I didn't want to think of the factors because I'm lazy. This method took the thought out of it. Ditch it, complete the square. I end up with on the left.
Positive negative x.
On the left,
Oh, x plus 3.
x plus 3. And on the right,
Positive
11.
positive negative
Positive negative.
11. And finally, when we move the 3 over as a negative, once again, this time we do get 2 separate answers.
14 and negative.
Ooh, careful.
4.
What's 11 minus 3?
8. Oh.
8. Negative 11 minus 3.
Negative.
Negative 14. Apparently 8 and 14 is how I would have had to factor 112. But I don't know those factors, so I'm glad I didn't have to worry about it. This is something we're going to do in Algebra 2 next year. I wanted you to see. No homework this evening. Have a wonderful rest of your day.